Guys, so today we're starting on 7b, which is the vertex form of quadratic functions. We've already learned the standard form of a quadratic function. By the end of this learning target, you should be able to put a quadratic function into vertex form by something we call completing the square. You should be able to identify the vertex in this form, in vertex form, and you should be able to graph it, identify key features like we did before. Okay? So although the standard form of a parabola has its uses, for example, it helps us really quickly identify the y-intercept, which is c, it's not very helpful for locating the most important point on the parabola, and that important point is known as the vertex, right? In standard form, we have to do negative b over 2a and then plug it back in to find it. However, in this lesson, we're going to learn about a form, vertex form, that lets us easily find the vertex. Okay? From there, we can determine how the graph moves and draw quick sketches of our graph. Okay? So our quadratic function in vertex form is f of x equals a times x minus h squared plus k. Right? So a we learned before that if a is positive, our graph will open up. If a is negative, our graph will open down, right? And also, depending on the number, if a, the absolute value of a is greater than 1, it'll be skinnier and skinnier and skinnier. And then the smaller a is, it'll get fatter and fatter. Okay? So the reason why this is vertex form is because h and k here together give us the vertex. Okay? H here represents the x value of our vertex and k represents the y value of our vertex. Okay? So let's start here. Without using a calculator, we're going to sketch the following parabolas on our own axis. Okay? It says here we just need to make sure that it's facing the correct direction and to state the coordinates of the vertices, right? So here, it's in standard form, a equals 2, b equals 0, c equals 0, right? So if we were to graph it, x equals negative 0 over 2 times a, this just gives me 0, okay? And when I plug it back in, this gives me 0 as well, and so my vertex is 0, 0, and then because a is positive here, it would go up like this, right? Okay, so same thing with this one here. A is negative 3, b is 0 here, c is 0. Okay, so same thing, x value for our vertex would be negative 0 over 2 times a. This is just 0 divided by negative 6, so that's just 0. To find the y value, I would plug it back in. 0 squared is 0. 0 times negative 3 is 0. So my vertex would be 0, 0 again. Right? And then since a is negative, it would open down. So what we can probably gather is that if we have a parabola in the form f of x equals ax squared, where bx and c is not there, then we have a vertex at 0, 0. Okay, so that's nice and easy, right? If we just have y equals ax squared, our vertex is going to be at 0, 0 at the origin. Okay? So let's consider the basic quadratic function here. F of x equals x squared, okay? And then we are going to look at the more complex quadratic function, g of x equals x minus 2 squared minus 4, okay? So the graph of f of x, y equals x squared here is provided. This, again, is the parent function, okay? So this here, again, is the parent function. From this original quadratic function comes all other quadratic functions like this. Okay? So the graph of f of x has been provided. We're going to use Desmos to sketch g of x equals x minus 2 squared minus 4. Okay? So here it is on Desmos. I'm going to graph it. So the vertex here is at negative 2, 4. So I'm going to graph it over here. And I don't have space. Let me scoot it over this way. Might be easier. Okay, so negative 2 comma 4, or sorry, 2 comma 4 here, right? 1, 2, 1, 2, 3, 4. So 2 comma 4. 1, 2, 3, 4. Okay, so there's my vertex. The next point here I have is 3, negative 3. So I'm going to plot that. Okay, mirror it over. Okay, next point here is actually my y-intercept here at 4 comma 0. So 1, 2, 3, 4. And then since here is my vertex, my axis of symmetry is here too. I'm going to mirror over it here. Okay. And then the next point I see is 5 comma 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 comma 5. Okay, I'm going to mirror over 1, 2, 3 for my axis of symmetry. 1, 2, 3. And then I'm going to connect my dots. Ooh. Okay, there you go. So it asked me, how would I need to shift or move the graph of f of x to get the graph of g of x? Right, so an easy way to see how the graph moved is by looking at the vertex, right? So the vertex here started at 0, 0, and then came to this position at 2, negative 4. What happened is it moved 1, 2, and moved down 1, 2, 3, 4. So what happened is it moved to the right 2 and down 4. So what are the coordinates of the vertex of g of x? So g of x here, my vertex is negative 2 comma 4. Right? Where do you see the vertex? Oh, sorry, it's 2 comma 4. 2 comma 4, my bad. 2 comma 4. Right? Where do you see the vertex in the equation of g of x? Well, I see my 2 right here, and I see my 4, or my negative 4. What is with me today? I see my 2, negative 4. 2 is here, that negative 4 is right here. Right? Okay, let's try another one. Okay. Let's see what happens when instead we add a constant after x has been squared. So here f of x equals x squared. Again, this is the parent function. From it we get all other quadratic functions. Okay. So we're going to consider g of x equals x squared plus 2. So we see that we added something after x was squared, or we subtract something after x is squared. Okay, so let's do x squared plus 2 first. Okay. That is here in blue. Okay. So let me graph it. Okay, so I'm going to do this g of x equals x squared plus 2 here. Okay. And so the vertex here is at 0 comma 2. So I'm going to do 0 comma 2. Okay. Next clear point is right here at 1 comma 3. So 1 comma 3, and I'm going to mirror it over from my vertex. Okay. Then the next clear point I have is 2 comma 6. So 1, 2, 1, 2, 3, 4, 5, 6, and mirror it over. Okay. And then connect the dots. Okay. So this one here is g of x. I did it in red. Okay. The next one here is going to be h of x equals x squared minus 4. I'm going to do that one here in green. Okay. So we're going to use Desmos to help us sketch it. So let me remove the x squared plus 2. This one is x squared minus 4. Okay. My vertex here is at 0, negative 4. So I'm going to graph 1, 2, 3, 4. Vertex here. Okay, then the next point I see clearly is 1, negative 3. So 1, negative 3. And then mirror it over. Okay. Then the next clear point I see is that x-intercept here at 2 comma 0. So 2 comma 0. Mirror it over. Okay. Then after that, the next clear point is 3 comma 5. So 1, 2, 3. 1, 2, 3, 4. 3 comma 5. Then I'm going to mirror it over. Okay. Then all I have to do is connect my dots. Okay. And this one is h of x. Okay. So let's put Desmos away for now and answer these questions. So what was the effect of adding a constant to the overall function? Right, so here with g of x equals x plus 2, what we notice is that from this parent function, when we added 2 after x was squared, the whole graph, the whole black parabola, moved up 2 spaces to get the red graph. Right. So then h of x, this one, instead of adding after x was squared, we subtracted, and what we notice is from the black graph to the green graph, what happened is the whole graph moved down 4. Right. Then it said to state the coordinates of the vertex of each parabola. So g of x equals x squared plus 2. The vertex here is at 0, 2. Okay. For h of x equals x squared minus 4, the vertex is right here at 0, negative 4. Okay. So predict the coordinates of the vertex of y equals x squared minus 150. Okay. So if g of x equals x squared plus 2, the vertex was 0, 2. H of x equals x squared minus 4, it was 0, negative 4. So I predict that if it was y equals x squared minus 150, the vertex would be at 0, negative 150. Right? Because what it did is it takes a graph and it moves it either up or down, which affects the y value of the vertex. Okay. So let's see what happens when we add a constant, this time before x has been squared. Right? So here again, f of x equals x squared is shown. This here is my parent function. From it, we get all other functions for quadratics. We're going to do g of x equals x plus 3 squared and h of x equals x minus 1 squared. Okay, so note that in the previous example, we added or subtracted things after squaring. In this one, before we square it, inside that parentheses, we're going to add or subtract something. Okay, so let's use Desmos to help us graph these. Okay, so we're going to graph g of x equals x plus 3 squared here. So here I use Desmos to help me sketch it. Okay, I notice that the vertex is at 0, negative 3. So 1, 2, 0, negative 3. Okay, the next clear point I see here is negative 2, 1. So negative 2, 1, and then mirror it over using axis of symmetry. Okay, then the next clear point I see is negative 1, 4. So negative 1, 1, 2, 3, 4. Okay, mirror it over. Okay, and then it won't fit in my graph anymore. So I'm going to connect the dots. Connect the dots. And then I'm going to label it so I know this is g of x. Okay. The next one we're going to do is h of x, which is x minus 1 squared. Okay, so let me pop that up on to Desmos here. Okay, so here I'm going to do it in green. So I notice that the vertex is now at 1, 0. So here's my vertex. Okay, there's a y-intercept here at 0, 1. So I'm going to then mirror it over. Okay. Then after that, here I see I have 1, 2, 3, 1, 2, 3, 3, 4. So 1, 2, 3, 1, 2, 3, 3, 4. I'm going to mirror it over. And then after that, it won't fit on my graph. So let me connect the dots. And there you go. Okay, so let's put the Desmos away for now. And let's see, right? So how does the horizontal shift feel counterintuitive, right? So what you should notice is that when we added to x, like we did here, inside the parentheses, it actually shifted my graph here to the left, right? So adding to x actually shifted it to the left, right? And so normally when we think of adding, right, we think of it'll move it right? But here actually adding to x inside the parentheses moved it to the left, right? Whereas when we subtracted from x here, like we did with h of x, instead of moving left where our negative numbers is, it actually moved right, right? And so that is why for our horizontal shift, it's actually kind of the opposite of what we see here, okay? Right, so when we state the coordinates of the vertex of each parabola, so g of x, which is the one here in red, right? The vertex here is -3, 0. Okay? So note that it is the opposite sign here, right? And so that's why I said that it felt counterintuitive, right? So -3, 0. Right? For h of x, which is x minus 1 squared, the vertex is here, and that is 1, 0. Right? And so note that even though it says x minus 1 squared, it's actually +1, 0 when we graph it. Okay? So that is why, right? So if you think about h, we often think about it as opposite sign of what we see, whereas the y value for that vertex is going to be the same. Okay. So here, determine the coordinates of the vertex of each of the following quadratics. Okay. So h, k, h, k, h, k. Note that a is irrelevant for the vertex. All a does is it makes it fatter or skinnier, opens up or opens down. Okay. So here, h, we think of it as opposite sign of what we see since it's x minus h. So that means my vertex is going to be 8, right? And then k is the same sign, so 5. Okay? This one, since it's x minus h for vertex form, x plus 1, it's because it's really x minus -1. Okay? And so h is going to be -1, again, opposite sign of what we see, because this x plus 1 here is actually x minus -1 in order to represent that x minus h. So it's -1, comma, k here is -4. Okay. And last one here, h, it's x minus h, so if it's x minus 3, that means h is 3. K is -10, and this is where our vertex is. Okay. That's it for today. Have a great rest of the day. Bye, guys.